Hi everyone. So today we're going to work on what are called rational exponents. So our goals today are that we want to write a radical as a rational exponent. We want to go from rational exponent to radical, and then we want to simplify some problems involving rational exponents. Okay, so I guess we better figure out what exactly do we mean by rational exponent. So rational exponent is an exponent that's a fraction. So something like 4 and then our power is 1/2. Or x, y in parentheses to the 2/3. Or maybe p to the 2/3, q to the 3/4. Okay, those are all examples of what I mean by rational exponent. Now, there's a relationship between rational exponent and radicals. Okay, so remember, radicals are like our cube roots, our square roots, our fourth roots, and then now we're going to deal with fractional exponents. And here's the relationship. Okay, that the nth root of a real number, m, is an integer, and m over n is in lowest terms, then a to the 1 over n is the nth root of a. Okay, so let's just stop there. That means that the index is the denominator of our fractional exponent. Okay, and if I have m over n, that means our denominator is the index of our radical, and the exponent is the numerator. Now this can be written two different ways, with the exponent underneath or in parentheses. Both are correct. Okay, so what does this mean? Well, oh, and by the way, m is negative and a cannot equal 0. Okay, so I want to write these in exponent form. So I'm going to do 36. Okay, now our index here is 2. It's a square root. So our denominator is going to be 2. And this is to the first power, so our numerator is 1. That's it. 36 to the 1/2. All right, let's try with this over here. So remember, there's no number with our radical, so this is a 2. So we get 5, and then our exponent is 3, and our denominator is 2. Okay, let's try this one. 16, our denominator is 4. Our numerator is 1. So if there's no exponent with the radicand, then it's just 1. Okay. All right. So 2xy. I'm using parentheses to say the whole thing. Our exponent is 3. Our denominator is 6. Now you can write that as 1/2 if you choose to do so. All right, let's try this one. So we get 12. Our exponent is 5. Our denominator is 3. Okay, so that's the key, that the index is the denominator and the exponent is the numerator. Let's go the other way. So we're going to write these in radical form. So our denominator is our index. So the 7th root of x. Okay, so that's this. And then our numerator is 3. So I can go like this and put it around the entire expression and write it that way. Okay, let's try this one. So 216 to the 1/3. So cube root of 216. It's to the first power, so that's all I'm going to do. So this is negative 5 over 8. Okay, so now first of all, the negative means 1 over. Okay, everybody remember that. 8th root of w to the 5th. Now you can put the 5th underneath if you want, or you can put parentheses around the whole thing. They mean exactly the same thing. p to the 0.2. Oh, what the heck are we going to do with that? Well, let's change 0.2 to a fraction. 2 over 10, which reduces to 1 over 5. So this is actually p to the 1 over 5, or the fifth root of p. Okay. All right, so let's go through that again. The denominator is the root, the numerator is the power. Okay, so we can write a radical. We're going to take our index and make it the denominator, and take the exponent and make it the numerator. If there's no exponent, we're going to put a 1. The same holds true here. We're going to take our denominator and make it the index. And we're going to take our exponent and our numerator and make it the exponent. If the numerator is 1, we can either write the 1 or not write it at all because it's understood to be there. Okay, now we can take these exponents and apply all of our exponent rules that we have. Okay, so we're going to multiply bases we add. Negative means 1 over. Power to a power we multiply, and so on. Okay, so all of these rules are going to apply. But we're going to do one more step before that. We're going to write our radicals as rational exponents, or fractional exponents, and then we're going to apply the exponent rules. Now, why do we want to do that? Remember how we said we couldn't multiply and divide radicals that aren't the same index? This fixes that problem. So let's see what we're going to do. Okay, so originally we couldn't do this problem because one's a fourth root, one's a cube root. We would say simplified. So once we write these as fractional exponents, so x to the 3/4 over x to the 2/8. Okay, so let's reduce that bottom, which we are allowed to do. There we go. Now we can use our exponent rules. So we're dividing, which means we're going to take our exponents and we're going to subtract them. Now remember, we're dealing with fractions here, so they better have a common denominator, which they do. So this is going to be x to the 2/4 or x to the 1/2. Now you can write it as the square root of x if you choose to do so. It would be up to the directions. Okay, so it says say write in simplest form. You can leave it as x to the 1/2 or x square root of x. I might, in directions might say, write your answer in radical form or leave your answer in exponential form. You just have to read the directions. Okay, let's try this one. All right, the square root of 3 times the fourth root of 3. Normally we wouldn't be able to do that. So the square root of 3 is 3 to the 1/2 times 3 to the 1/4. Now we're multiplying bases, which means we're going to need to add our exponents. So that means 3 to the 1/2 plus 1/4. Well, that's not going to do me any good. I don't have a common denominator. So let's take care of that. So 3 to the 2/4 plus 1/4 is equal to 3 to the 3/4. Or the fourth root of 3 cubed. Okay. Let's try another one. All right, so here we have negative 8x, xy to the 1/2, whole thing taken to the 2/3 power. Now I'm going to put, okay, that's what we're doing. Because I changed my radical to 1/2 power. Everybody's being taken to the 2/3. So that means everybody gets one. So negative 8 to the 2/3, x to the 2/3. All right, and then I'm going to take these two and I'm going to multiply them together. So that's x to the xy. Let's do it this way. To the 1/3, and then I'm going to give everybody a 1/3. 8 to the 2/3, x to the 2/3, x to the 1/3, y to the 1/3. Okay, can we do anything? Well, these guys, the x's, can be added together. The base is already the same, so we can just add our exponents. And the denominators are the same. So negative 8 to the 2/3. X to the 3 over 3, which is 1. Y to the 1/3. Okay. All right. Okay, so I'm going to do the cube root of negative 8 squared. Okay, and then this is just an x and this is y, the cube root of y. Okay. All right, so cube root of negative 8 is negative 2. Negative 2 squared is 4x cube root of y. All right, let's try one more. Okay, so here I'm going to give everybody to the negative 3/4 power. 16 to negative 3/4. And y, okay, so we have to do like negative 8 times negative 3/4. It's still here. So negative 8 times negative 3 divided by 4. 6. Okay. Now the problem is that's a negative, so I got to do 1 over. So 6 over 16 to negative 3/4. Oops, positive 3/4. Hate when I do that. Okay. All right, so let's clean this up a little bit more. Y to the 6th, 4th root of 16 cubed. Okay, what's the 4th root of 16? We said 2. Okay, so 2 cubed is 8. There we go. So we're applying our properties. These last two are the tough ones, especially number 3. I probably could have done that a little bit better as far as like process goes. All right. Let me know if you have any questions. Hopefully we accomplished our goal, that we were able to simplify rational exponents, write them from radicals to rational exponents. So go from radicals to fractions, from fractional exponents back to radicals, and use our exponent properties to simplify expressions with fractional exponents. All right, guys, let me know if you have any questions. Please stay safe, and I'll talk to you again real soon.